2 graphs, so you do need 2 of these graph papers today. Okay, and this is our last lesson of the trimester. How exciting. Okay, so exponential growth is a way that the graph is going to increase rapidly. So it's going to grow really, really, really fast. Okay, so that's why it's called growth. And this happens when it's b to the x power. So x is actually the exponent this time. Okay, so whatever we're taking to that exponent, b has bigger than 1. Okay, nope, you can't see all of that, sorry. Okay, so the graph increases rapidly. Oops, I should say increases, I guess. Okay, decay is the same idea, but this time the graph is going to decrease rapidly. So it's going to get smaller, 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 smaller really fast. Okay, and again, that happens when if I have a b to the x power, whatever I'm taking to that exponent, if that b has to be between 0 and 1. So usually we use fractions with exponential functions. So if we see a fraction that's less than 1, that's going to tell us that it is decay. All right, when we graph these, there's not really too much to know. We're just going to go straight to the table, and then we're going to still do, and then we make the we're going to go straight to the table, then we're going to make the graph, and then we're going to just still identify that domain and range for us. Okay, so for mx equals 3 to the x power, so this is our function m, we're going to create our table x, and then m of x. And for a table with exponential growth and exponential decay, we are going to just use -3, -2, -1, 0, 1, 2, 3. We're just always going to use those numbers. Now we might not be able to graph everything onto our graph here, but it's going to give us an idea of what that's going to look like. Okay? Because it grows so quickly, sometimes it's going to go off that graph really fast, or sometimes if it decays, it's just really hard to plot some of those decimal points. So in this problem here, we're doing 3 to the x power. So I'm going to do 3 and then an exponent. Now this is the x, so this is what's going to change here. So we're going to do -3. We get 0.037, so that's really close to 0. Okay, then instead of -3, I'm now going to do -2. So I'm just deleting the -3, -2, and that's the exponent. We get 0.11111. And that little line, remember, means it's repeating, 1111. If you wanted to write 11 there, you could. Oops. So instead of -2, I'm going to do -1, and that's 0.3 repeating. Now instead of -1, we're going to do 0, and we get 1. Delete the 0, put in 1, we get 3. Put in 2, 3 squared is 9. And then 3 to the third power is 27. Alright, so this one it's growth, because as we see it's going to get bigger, 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 bigger as we go more positives. So now let's plot these points. We have -3, 0.037. So just barely above that x-axis. -2, 0.1. So again, just barely above that x-axis, a little bit higher, but not much. Same thing here, it's just barely above. So those are all really close together. They're all really small numbers. But then when we hit 0, we get 0, 1, 1, 3, 2, 9. So this goes up to 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to estimate it's way about here. And then we have 327. So 327 is like way up there. It's going to go way off the graph. So we won't plot that one. But then this is going to look like a curve. And this is going to get really, 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 really small, but it's never actually going to touch that 0. That's called an asymptote. We're not going to talk too much about an asymptote today. But we get this curve where it's going to keep going up and up and up. Okay? So for this one, if we do our domain and our range, I didn't really leave too much space for that, so we'll just sneak it in here. Okay, domain is left and right, so this is always going to keep going left, left, left. This is going to keep going right, 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 right. It goes up, but it goes to the right. So domain is all real numbers. And then for our range goes up and down. And our range isn't, it's going to keep going up, 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 up in this case. When we go to the right. When we go to the left, it's going to keep getting closer and closer and closer and closer to 0, but it never actually touches it. So we see that's going to keep getting to 0, 0, 0, 0. And we see that here when it goes 0 0.3, 0 0.1, 0 0.037. If I sneak a -4 in there, okay, if I put -10 in there, again, that's a really, it's kind of hard to understand, but that's really close to 0, okay? So it's going to keep going down, 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 closer and closer to 0, but never actually touches 0. So our range is y is bigger than, because it's going above 0. And it doesn't ever touch 0, so we don't do that equal to. It's just y is greater than 0. All right, we have one more example. This one's a little bit more complex. We put in a couple more things, but it's the same idea. So this time when we make our table, it's a little bit easier because we're just going to use the same numbers every time. Okay, so this is function w. We have 4 times 1/2 to the x power minus 2. And we're just going to use -3, -2, -1, 0, 1, 2, 3. So I have 4, and then 1/2, and then it's going to be raised to the x power. Whoops. So we'll start with -3, and then -2. All right, so when I put in -3, this time we get 30, so that won't be on the graph, but we'll work on it. Okay, and then it's the exponent. So I'm going to go to where this -3 is and delete that -3, and that's going to be a -2. And we get 14. -1, we get 6. 0, we get 2. Put in a 1, and we get 0. Put in a 2, we get -1. Put in a 3, we get -1.5. So on this one, we might not see where it's going to go. We'll talk a little bit after we graph. We might need to plug in a couple more numbers here, but we'll see. All right, so -3, 30 is going to be way off the graph. That's huge. -2, 14. That's still enough off the graph. It'll be difficult to put that on there. So I'm going to start with -1, 6. If this was a really important problem that we like had a word problem for that we really needed to see that graph further on, we would either get a bigger graph or we would count by like fives instead of just counting by ones. But today we're just doing our introduction, so we're just going to count by ones. 0, 2, 1, 0, 2, -1, and then 3, -1.5, so halfway there. Okay, so we can see that that curve is starting to happen, this curve that was up here, but we aren't really seeing where it's going to go to. So I'm just going to keep plugging in a couple numbers to finish out that graph. So 4, we get -1.75. I put in 5, -1.8. So now we can kind of see it's not going to ever get to that 2. It's going to just kind of keep going and going and going. So this time, this is a decay because it's going to get smaller as we go to the right. It's going down. Okay, so this is a decay. The other one was a growth. I should have written that there. Sorry. So this one's a growth because it keeps going up, up, up. As we go left to right, it's going to grow. It gets bigger. This one's a decay because as it goes left to right, it gets smaller. So this one is a growth. All right, domain and range real quick. And then that is it for notes for try 2. Domain is left and right. This is going to keep going right, 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 right. This keeps going left, 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 left. So domain is all real numbers. And then our range is our y's. So this is going to keep going up to the left. It keeps going up, 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 up that y. But as we go down, it stops here. It's not ever going to touch that -2. It's going to keep getting closer and closer and closer, but never actually touches that -2. So our y is greater than -2 because it goes above that -2. And those are the notes for trimester 2. One trimester left.